we've been talking about momentum, and momentum is how difficult it is to stop something from moving. Momentum is the symbol P, which is equal to mass times velocity. So a locomotive, which has a huge mass and maybe it's got a high velocity, will have a massive, well, that's a bad word to use, will have a huge momentum. Be very difficult to stop. And now we go on to a very, very important law of physics. In an explosion or a collision, the total momentum before the explosion or collision is equal to the total momentum after. Now that is a fundamental law. It's one of the most important laws of physics, called the law of conservation of momentum. And it enables us to make calculations of objects moving, exploding, colliding, and to predict what will happen to objects with regard to their speed, or their velocity rather. So let's illustrate this by an example of an astronaut. Maybe you're an astronaut and you've gone on a spacewalk, and unfortunately you've become untethered from your spaceship, and you're sort of floating there, maybe several meters away from your spaceship, thinking, oh my goodness, I've got to get back. How am I going to get back? Well, luckily you're carrying a very massive hammer, which you've been using on your maintenance. And so if you're smart, you'll realize that if you throw the hammer as hard as you can away from the spacecraft, then you will be pushed backwards. And the reason for that is to do with Newton's third law, that every force has an equal and opposite reaction force. So that's action and reaction. So the force of you on the hammer will be equal and opposite to the force of the hammer on you, pushing you backwards. Now this is reflected in the law of conservation of momentum, because the momentum before your explosion, if you like, because it's sort of an explosion, you're throwing the hammer away from you, has got to be equal to the momentum after your collision. So if we add up all of the momentums in this before case, it has to be equal to all of the momentums of the objects in the after case. In the after case, let's treat this way as positive and this way as negative, remembering that momentum is a vector, and vectors, the direction is important. So if you manage to throw your hammer with a momentum of -5 kilogram meters per second away from you, what would be your momentum? Well, it's going to have to be +5 kilogram meters per second, so that when you add that up, that's your momentum, with the momentum of the hammer, +5 - 5 equals 0. So the momentum before will equal the momentum afterwards. This is the law of conservation of momentum, and we can use that result to work out how fast you will have been thrown backwards by throwing the hammer forwards.